So the last classification we want to talk about, and hopefully um, relatively quickly, is even and odd functions. So this is not really the same as even and odd numbers, although obviously the words are the same. Um, we're talking in this case about some kind of symmetry of the graph. So a function is even if for all x in the domain, the opposite of that input also exists in the domain. Kind of think about it as our first criteria. And the big test is if I have f of negative x, it's the same as f of x. So the number and its opposite return the same value. It's kind of our second criteria. And the graph of an even function is symmetrical about the y-axis. Right? And my kind of go-to example here is something as simple as x squared. Right? Something as simple as just like an ordinary parabola, just like this, sort of. And if I were to draw this more perfectly, you would see that the line x equals 0, right, the y-axis, acts as a sort of mirror between both halves of the graph. So we can kind of see that this graph is even, but we can also check it algebraically by plugging in negative x, and this just gives me x squared, which is the same as the original function. So therefore, it's even. On the other hand, we have odd functions, and under the same sort of initial conditions, right, for every single x in the domain, its opposite is also in the domain. That's really important. And the big test is to say that f of negative x equals negative f of x. So if I've got an element in the domain and it returns a value in the range, plugging in the opposite of the domain element gives me the opposite of the range element. I guess this should be 1 and 2, huh? Not 2. And my go-to non-trivial example, because of course y equals x will work here, that's because the graph of an odd function is symmetrical about the line y equals x. But a non-trivial example of this is to look at x cubed. And if I really quickly try to sketch the graph of x cubed, it's going to look kind of sort of like that. And if I were to overlay the line y equals x, again, not perfect because I did it by hand, but you can kind of start to see that there's sort of a mirroring between the top part and the bottom part. I can, of course, check this algebraically. I can do this by plugging in negative x to actually apply my test here. And if it all goes according to plan, which it does, I get negative f of x, and therefore odd. So I've kind of just shown you the test and shown you the examples, but just to take you through the examples, just to save some time, I'm going to check only a couple of them graphically. But you can, of course, check my work on your calculator. Prove algebraically. For even odd, if I say prove algebraically, your test is always to plug in negative x and to see where we go. So if I plug in negative x, and then I simplify, I'm going to get 3 minus 2x squared, which, as you can see, is exactly the same as f of x. So therefore, f of x is an even function. Same idea with g of x, right? If I evaluate negative x, I'm just going to start by plugging that in everywhere. I'm going to get negative x minus x cubed. And especially while you're getting in the habit, and I'm sure IB would want to see this step too, show me explicitly that I really do have negative f of x. I have negative, or I guess g of x, I'll have to change that in a second, right? G of x if I want to use the proper names here. Show me explicitly that these really do match. And that'll help you recognize it too. A lot of times it'll be hard to see outright without doing that manipulation to really explicitly show it as negative the function. And then with part C. Well, with a piecewise function, we're just going to check, well, both the pieces and under the same conditions. So this would be negative x plus 6 and x. No, sorry. negative x minus 6 and x plus 6 under the same conditions, I believe. And actually, whether or not they're under those conditions or under the opposite conditions, it would not make a difference here because very clearly these functions are not opposites of these functions, and they're not the same either. So this function is neither even nor odd. I can kind of check these quickly graphically, right? My parabola is still centered somewhere on the y-axis, so there is that mirroring. I'm not going to attempt to guess the sketch of the graph of b, so you can try that one on your own. And then my piecewise function, though, I know is going to look something like this, which has no symmetry whatsoever, so clearly neither even nor odd.